Welcome to our channel. Welcome to home. It looks like this.
So, welcome to our channel, guys. Today I'm joined by our little witch Nimueh and Anthony, who's a werewolf today. We are going to be setting ourselves the challenge of doing an experiment a day of a Halloween themed nature. And today we're starting with states of matter. So, our first experiment is states of matter. As you can see here, we have our salt water solution, we have cold water, and we have hot water. And we're going to see which one affects our ice coffin the most. And we use simple food colouring for ours. We chose orange. So what I want you to do is take a pipette. Well, we're using syringes. I want you to take a syringe each. Yeah. And choose a solution.
And this one.
And then you're going to drop it on the ice. And you're going to see what happens to the ice.
And this
okay?
one.
And you're going to see which one dissolves the ice fastest.
And this one.
Okay. Which one do you think will dissolve the ice fastest, Nim? The salt water, the hot water, or the cold water?
I reckon the hot water.
Do you?
I reckon the cold water.
Okay, well, we shall see. So, Nimueh, what's in your syringe?
Salt water.
And what's in yours, Anthony?
Hot.
Hot water. Okay. Right, go on then.
Go on.
You see what's happening to it?
What's happening? Is it the hot water? Or is it...
It's starting to change state. So the water is going back to its liquid state. Because when we froze it, the liquid water became frozen water, didn't it? So it changed its state of matter.
So which one?
And it's now reversing back to its liquid state. We're on to our second syringes. Anthony, what's in yours?
Salt.
And what's in yours, Nim?
Toad.
Well done. Do you want to have a little go? And look close for any changes.
Is any changing to me?
Oh, it does look like it's melting.
Cold water.
Our third syringes. Salt and cold water. Go on, Nim and Anthony. Oh dear.
I'm wet.
Look, it is changing its state, isn't it?
Can I touch it?
You can.
Oh my god, this is like ice. It's like cold ice.
Well, it is cold ice.
Like cold ice, like a liquidy cold ice. Oh, this bit is melting. So, because we pulled it over here, it looked like whatever she used melted it.
She was using the salt water. Shall we try pouring the rest of the salt water in?
Let me. Ha ha ha. Can I put all of them in?
Yeah, go on.
Let me put one in. I'll try over mine.
Would you like to pour some actual salt onto it?
Let me do it.
Just a little bit then.
Look, that onto it.
You see what the salt does? What's the salt doing? Oh, that's enough, I think.
Can I touch the salt?
What's it doing to it?
Is it melting it?
Quite fast, isn't it?
Yeah. Let me touch the salt.
So what do you think melted the ice the quickest?
Salt. Salt.
Yeah, that's clever.
My hand. Can you get some baby wipes?
I will do now.
I'm using the water.
With the ice.
Look at this. I'm wet. We'll do like be wet. You want some wet? Yeah, you hold that. It's like when you go to like somewhere what has a bunch of ice on the floor and you touch it. Yeah. The salt is making it even colder though. Yeah. It's like sea. It's like the sea when you walk into the sea. What? Where's it?
So,
I'm not always
shush. Change in state is the process of turning solid into gas or liquid by changing its temperature. Everything we see, touch or smell is made of matter. States of matter cannot be destroyed, but they can be changed into a different state. So that's what we've been doing today. Our example of states of matter for today cannot be destroyed, but can be turned into another with the addition or removal of heat. So what we've done today, we've discovered melting by freezing a liquid to a solid and then changing that solid to a liquid by melting it.
It's melting even quicker now.
It does.
It's so cool. Look.
So cooling water to 0 degrees turns the water into ice, which then becomes a solid, and that's called the freezing point. You can also turn water into a vapour, which is a gas, by heating it up to 100 degrees, and that is called the boiling point. Today, we have been playing with freezing points.
Are you wet? Thank you for joining us today. Welcome to our video. Welcome to home. It looks like this.
Today, we're going to be making glowing flowers. And pale flowers are the best because they show up the colours better. And we'll be popping ours under a black light. This experiment takes several hours to complete because it has to soak up the stem and into the flowers. So, let's get cracking. So, for this experiment, we're going to be using highlighters. And we're using yellow because they tend to be the most fluorescent. So the first step is the water in the jug, which as you can see we've done. And then each child is going to add into the jug a marker.
Yeah.
So do you want to put the inside of it in? You've both got one each. Put it in the same jug though.
That's sick. This is actually...
Yeah, put them in there. Well done. So the next step is to add that water, and as you can see, very bright, and that's without being under the black light, into our cups. We're using pint glasses for ours so they can see the process. So we'd just like to pour a bit of water into your glasses each.
Me first. To there.
Yeah, just a little bit. You're probably best letting Anthony go first because then it'll be lighter when it comes to your turn. Go on, Ant.
Is that it?
Right, that'll do. Would you like to pour some in yours? We can always top yours up in a minute, Anthony. Slowly does it. Keep going. Watch what you're doing. Run a bit more. Like that'll do. Would you like a bit more, Anthony?
Yeah. I
Don't touch it. Remember, it's not drinkable.
I'm only
Put a bit more in hers, Anthony.
Let me do it. Put it in.
Good girl.
Can I make mine full?
Go on.
All the way full?
Yep.
So you mean all of it?
Go on. And next, we're going to put our flowers in.
My first. My first.
Go on. Pop them in. And now our flowers have to sit in the water for a few hours. And then later on tonight, we'll put them under the black light and see if the actual flower petals themselves change colour and glow.
Now.
Well, we have to wait for a few hours first. Because we have to see it soak up the stem and into each of the petals.
What if they change like a greeny and yellow?
Oh, it might do. What colour do you think they're going in?
Green.
You think green?
Yeah.
So you think it's going to glow green under the black light?
Yeah.
What about you, Anthony?
I reckon one of them might be half green and half yellow.
You never know. We'll have to wait and see, won't we?
I think this one will be green and this one will be red and this one will be
Red?
yellow.
Where are you getting the red from?
There's no red. Just seeing the night. Nimueh's glass is cool because if you look at it on this angle, one half's yellow and one half's green. Nice.
It's the way the light's hitting it. Hi guys, so we're back several hours later and we're going to check and see how fluorescent our flowers are. For this we need our black light.
It's like Emily's lab now, isn't it?
Is it like Emily's lab?
Yeah.
As you can see, our flowers are not yet fully fluorescent, but they are just starting to turn. Look at the bottom.
Oh, we don't.
These ones.
The
bottoms of them are starting to go.
Glowing.
And just the tops of the petals are glowing slightly as well. It's not just the bottoms, it is the petals too that are starting. We'll check this again tomorrow and see how much it glows then. Say bye, guys.
Bye. Let me put my...
Right, welcome back everyone. You're going to give a wave, guys. So, it has been 24 hours since we last checked on our fluorescent flower experiment. Cut flowers do not have any roots, so the liquid moves up the stems and into the leaves, and that is called a capillary action. The water moves along these capillary tubes, up the stem and into the leaves and petals. The veins on leaves are actually visible capillaries. We dissolve fluorescent, non-toxic ink in a glass of water before putting our flowers into the mixture. As it is non-toxic, it will not kill the plants. Right, shall we see whether it's worked, guys? Yeah. Shall we see whether our flowers are fluorescent?
Yeah.
Wow, look at that. If you put it underneath, you might be able to see it a bit better. Be careful, Nim.
Oh my god. You see it in the dark, but when you shine it on. But when you shine out the light, that is why it's really cool.
Watch your eyes. Don't shine it in anybody's eyes, please.
Stop. I want to see this one. Green.
Is it changing colour?
Look at that. It's turning purple. It's turning purple. Oh my god, it actually is. Yours is turning purple like mine. Oh my god. That's turning purple. Dad, yours is what? Oh my god. What happens if you take the flower out of it?
Right, take it out. Give it a little shake. Shake it over the glass. Clever.
I just on the table.
It's fine. We'll wipe it up.
Now, if any of the parents watching remember Cyberdog clothes of the late 90s.
Mum,
Yeah?
mine is fully
Hold it
wet,
still.
so all I'm touching is wet.
See if I can get it. Hold it still. Just hold it still. Oh, that's pretty.
Mine is actually turning purple.
It is.
I'm green on this side. Mine is just wet and all I'm touching is wetness.
Look.
It's fine.
Oh my god, my hands are glowing. Look.
Oh my god. Oh my. Oh my god. Look.
It's your hands, guys. Do 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 do.
Learn how. Can we touch the water?
No, I wouldn't touch that. It's non-toxic, but still, just to be on the safe side.
We're down in the dark. Let me touch that. Let me touch that flower.
Right, you're gonna say bye, guys.
Bye.
Right.
I'm a witch.
Welcome to our third experiment.
What are we making today, Nimueh?
Can't remember. Oh, yeah.
We're making a witch's brew.
We need potion.
Yeah.
We're making a witch's potion.
Okay.
And you're a witch, so you.
No, I'm a wolf, so you need to teach me how to make potions. Let me transform back.
Now I can teach you how to make potions. Fish you need to have.
Well,
you
wait
need to
there.
learn, and then that.
I think we should leave it to the master witch.
Oh, thank you.
And
Right, well, I'll talk you both through the process. Do you want to sit back down, Nim?
Yeah.
So I can get you in the camera shot. So, the first thing we're going to add into our cauldrons, and you're very lucky because you have cast iron cauldrons, is the baking soda.
No.
So next, we're going to add the dish soap.
What's this?
Okay,
Hang on.
that's this one here. So, would you like to add 2 tablespoons of that each?
That?
This.
Yeah. Oh, that looks gloopy. Go and add it in your cauldron.
Well, wait, could it be frogs? Could it be frogs goop?
Go and add another one, Nim.
What is it?
Oh,
Is it out of frogs?
slime.
I know what
Magic enchanted
I know what we
slime.
should name it. I reckon we should name
Wait,
it.
monsters one.
No, I reckon we should name it frog spit.
Frog spit. Okay, well, do you want to put a couple of dollops of frog spit in yours?
Ew. Look at the frog slime. Slime.
Frog spit.
Slime frog slip.
Okay, our next step is to add our vinegar. However, wait. Sit back down. However, if you're wanting to add food dye to it, you need to do that first.
Anna, do you
Food dye.
Okay. So, our next step is to then add that to our cauldrons. And you have to be fast, so you'll have to pour it in. Don't use the spoon, just pour it in.
Where are we meant to go then?
Straight into your cauldron, quick.
The vampire blood is making it go bigger. Hot.
Don't touch it. Don't eat it. It's not edible.
Oh my god.
Oh my goodness.
They are some fancy potions.
I am now a witch. Wolf. A wolf.
A wolf witch.
A wolf witch. A wolf. A wizard.
A wolf wizard. Okay, we'll go with that.
And I'm a.
More?
Just do it.
Look at that bubble.
Goodness.
Wait, it hasn't popped.
Oh yes. Sister. I'm talking to you, sister.
Oh, I'm sister, am I?
Yeah.
Okay.
Sister.
Why my sister?
Because my sister's in here.
Okay.
I think she's calling you. I think she's calling your sister from Hocus Pocus.
Ah, that's fine.
Sister,
Yes, sister.
look at our potion.
I am.
Oh, I'm gonna be turned into a frog soon. Ribbit, ribbit.
We don't like frogs, do we?
Ribbit,
Sister.
Of course we do. They're lovely in potions.
ribbit,
No, we don't.
ribbit,
We
ribbit, ribbit.
don't like them. Don't
Okay, I do. I like
I want
frogs.
to turn it blood of the vampire.
Right, say bye, guys.
Bye.
Hi guys, welcome to Homemade Looks Like This. Today we are going to be making flying ghosts. Ooh.
Right, so to start off, we're going to have to open our tea bags.
This is what we
Do it slowly.
and some dots.
Are you going to draw a spooky face on yours, Nimueh?
With some spooky eyes and a spooky mouth. Gonna do your mouth.
Crazy lips. That's his lips.
Do you know what I'm gonna draw? Actually, I don't know.
That is very good. Spooky
Oh,
face.
that is brilliant, Nimueh.
It's a very spooky thing.
It is.
No.
Should we stand yours up ready? We'll light them at the same time. And this is a really, really quick and simple science experiment you can do at home.
You have to make sure that the edge you cut is really straight as well, otherwise it won't stand up.
I want to see his face. Like, mine's still to be
Right,
red.
do you want to try and stand yours up? That's really good, Anthony. It looks like a vampire.
Can I see?
So we have a vampire ghost and a pumpkin ghost by the looks of it.
It's not a vampire. It's meant to be a wolf and a vampire.
Ah, a hybrid. I like it.
So the wolf teeth going up, but it's also mixed with a mammoth from the dinosaurs. So it has teeth going up that way and teeth going up that way.
Okay, 2 minutes, guys. So the next step is to set them in fire, and you light them at the top. And this is for a parental role.
This is the fun bit. You gonna help them?
Yeah.
And you hold Daddy's hand as well. And step back. Go blow it.
How will we blow it?
Magic.
Oh, magic!
Should we do your one, Anthony?
How will we blow up a dam?
You can do another one in a minute.
I think it fell.
It's okay. Right, Anthony, you're going to do your one. Just waiting him.
Oh, should we see when it goes big?
Ready?
Oh, work the magic. Wow. Can anyone tell me why they think the tea bags fly?
Because of the wind.
No, because
Very
of the magic.
Because of the magic. That's also true, because science is very much like magic at times. So, there's 3 different forces that are at work. Are you listening?
Yeah.
Okay. So as the tea bag burns down, the air inside the bag heats up. And when the air heats up, it becomes less dense. And when air becomes less dense, it rises. So as the air inside the cylinder tea bag becomes warmer and less dense than the air outside the cylinder, it rises up in the air. The second thing that makes them rise in the air is the hot air inside the burning cylinder. Because as the flames heat up the air inside, it becomes hotter than the air outside, and the cool air rushes in to take its place, creating something we call a convection current. And in this case, the convection current pushes up from the bottom of the bag and makes our ghosts fly. And then as the tea bag burns, the smoke rises and leaves behind a very delicate, lightweight frame of ash. And it's so lightweight that it's easily carried into the air by the hot rising air and convection current. And it looks like a spooky flying Halloween ghost.
But it's magic though, isn't it?
Isn't science magic?
Time to make some models.
Can we?
Yeah. Should we make more?
Yeah.
Yeah.
Awesome. To expand our experiment, we're going to try different shaped and different size tea bags. Should we try your one?
But you didn't do it. 2 sides.
I think Anthony's might actually have a better choice because the air going up will get caught in the top a lot easier.
Might work
You
better.
need it to stand up. See, this is where you need a Tetley's pyramid bag.
Well, what about he likes it himself?
You might have to fold it.
Is he allowed to like it himself?
There we go.
Is he allowed to?
No, he's still too young to light it himself. Let's see if yours works, Anthony.
Oh.
Oh, nearly. Yay!
Hey, I knew it would work. I knew.
Well done. Your scientific process, Anthony, proved you right
Goes in one hole.
because you were able
You
to
just go in the
compare.
big hole, okay?
Well done.
Because if you look at it this way,
And that
because
comes in.
with these tea bags, it's different.
Mm.
Because they're not that big.
The different shape.
Yeah, and so if you cut both ends, there's nothing stopping it from air going up
Yeah.
to rise it. So I thought it might work that way.
Well done.
I'm gonna try.
Remember to stand back, Nim.
Ow.
You're gonna get the hand.
Be careful. Watch your face. Come quick, me back.
What's happening?
Sweet. Wait. Hey, is it good? Yay!
That one went in the That one flew off.
Right, should we try Anthony's? Come in.
I almost
Push the
fell.
flowers.
Safety.
I bet he's in.
Everybody stay back.
Aww.
I reckon that if we light both sides, they'll go across the top and make an even column. As
Okay.
opposed to burning across the because they seem to be falling over to one
Yeah.
side and they're not quite lifting right.
Do you want to try it then?
That is my
Or light it in the middle?
so that it goes out both ways.
Mm. Ah. Prepared. Let's test this theory out. Work the magic. Is it going to do it? Yay! Daddy caught the ghost.
Blue.
And there we go. I'm not doing any face of mine. I'm not doing any face of mine. Why? Because I don't know.
I guess.
Is yours ready to light then, Ant?
Yeah.
You got me in. So we'll do
No, do it there.
in the middle.
Yeah.
In the middle on this one.
I reckon it's gonna go
Okay.
super high.
Like mine did, yes.
You ready?
I don't know.
Pac-Man.
Ah, it does actually look like a Pac-Man ghost as well.
Wait, what about it to be
Take a
the
screenshot
one,
of this.
the one with the yellow hat in Paw Patrol that ate the turkey on the dose one?
Take a picture.
In
I zoomed in.
the creepy one.
Okay, are we ready then?
Right, are we ready?
Dum 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 dum.
I think this one's gonna fly.
Fly.
Way!
The ceiling. Do you know what? I'm doing mine on this. No, no, no.
Come on. Like yours, Anthony. It's blinking at me.
No, it's on there. Come on, everybody, do it. Do it. Do it. Be the good luck tray. That's the
Way!
good luck tray. I'm telling you. No.
Right, is everyone gonna say bye?
Bye.
Hi guys, you gonna say hello?
Hello.
So today, as you can see, we're covering freezing point depression. The first stage is to actually make our ice cubes, and this experiment also ties into changing states of matter. To make the ice for our experiment, we're using round silicone molds. So Anthony, do you want to make your free? So Anthony's going to take the funnel and insert it into the silicone mold and then pour water, and they've both got 3 each. So welcome back, and we're finishing off our experiment on freezing point depression. Say hi guys. Okay. Freezing point depression occurs when the freezing point of a liquid is lowered or depressed by adding another compound to it. The solution created then has a lower freezing point than that of the initial item, which for us is our ice spheres. Do you want to hold up your ice spheres? Show the cameras.
Cold, slimy.
You can put it back down now.
You can see it you can see the inside. Oh, it's melting really quick.
Okay, so in our first cups, well, in each cup, would you like to pour some water in?
Yep.
Anthony, you go first because it'll be too heavy for Nimueh.
Oh, it's just melting already.
Yeah, we're gonna have to be quick. Pour it halfway.
So in the first cup, you're going to add some salt. And you need to add quite a bit of salt.
Quite a bit of salt.
Yeah, come on. Use some of your syringes to actually start melting your sphere.
You have to melt it.
Mine will melt.
What do you think the salt would do to it, the salt water?
Scrape across it.
No, melt it.
Clever girl.
Because last week, what did it do? It melted it.
Clever girl, Nimueh.
So, I think it will melt it.
I think it will melt it, but by scraping across it.
Let me just zoom in on what you're doing.
How's Nimueh's melting and mine's not?
Yes, it is.
Mine's not melting.
Nimueh put an awful lot of salt in hers.
Yeah, but what's this for?
For the So as we can see, because salt water has a lower freezing point, it's helping to melt the ice.
Mine's not even melting.
We can show this better by using coloured water.
Wait.
So, do you want to put your currant cups away to one side and pop your balls of ice in them ones, the ones that are on your tray so far? In our next cups, we're going to add paint to the water. Would you like to put 2 squirts of paint in each?
Yep.
Me first, me first. Me
No, you can both do it at the same time.
There. Let me open it. There.
Go on, crack on.
1 squirt. 2 squirt.
That's enough, Nim.
That's enough. That's enough.
Oh, Lord.
You're very eager there, Nimueh. Would you like to give them a stir using your wooden stick?
Let me get mine.
Okay. So 1, 2, 3. Fingers. Would you both like to start painting your ice?
Yes, yes.
Yep.
Painting.
Yeah.
Go on then.
Drop the paint on your ice.
I
Using
don't.
that pipette.
You will see the tunnels the paint causes in it. You'll see the effects going inside it as it melts the ice.
Look at mine.
Oh.
Mine.
Oh, well done. That looks lovely, Nimueh.
I mean,
Getting covered.
I'm better than what we did to me.
So welcome to Home Ed Looks Like This, and Nimueh has hiccups.
And probably I pick up.
Whoops. Well, this is going to be a fun video, isn't it?
The Nimueh doing hiccups.
The Nimueh doing hiccup show. Right, so today we're going to have some fun and do some UV art. But we're going to combine it with our studies on states of matter. So we're going to be making ice cube paint using neon luminescent paint. There are 3 types of luminous paint. You've got fluorescent paint, phosphorescent paint, and radioluminescent paint.
Oh no.
We are using fluorescent paint, also referred to as neon paint, which will react under a UV light, giving our works of art a... Can you see what it's doing in the ice? Can you see the little pathways in the ice?
Yeah. Look at I've done fair emo.
They're called tunnels.
I've done fair.
And that shows
I've done a fair
the breakdown of the ice as it changes its state of matter.
State of matter.
Which is where it goes from a solid, in this case, to a liquid.
It's falling down. Wait, so we
If
put,
you look, that one creates the tunnels a bit better. The pipette. You can see the tunnels on it.
No, I can't.
You can see the little holes that it makes where it drops on. Watch your eyes.
Time to pour.
Fluorescent paints glow when exposed to long-wave ultraviolet radiation. The fluorescent chemicals in the paint absorb this UV radiation, then release it as longer-wave visible light that glows under the human eye. It's a different process from nature's bioluminescence, which we will cover at another time. So, the first step of this experiment is to make our ice paints. So, each one, Anthony's chosen his 3 paints and Nimueh's chosen their 3 paints. So they're going to have 3 ice cubes of paint each. So to start this, we're going to put a blob of paint into each one of the trays in front of us. So the next step is to then pour water in on top of each of the paint, okay? So take it in turns. That might be a bit heavy for you, Nim. So the next step is to then stir each one so the paint mixes evenly with the water. So a different stick for each. Right, the next step is to then pop these into the freezer. Did you not realise it was still recording? Right, say bye for now.
bye.
Welcome back, and this is our UV art class. So we froze our paints earlier. Can you remember whose colour was which?
Yeah.
Go and pick your colours.
This bread. These bread.
Yeah.
The paint's bread.
The whole point's going to go on your paper.
This red.
Yep.
Yep. Doesn't look like red.
There are your colours there, Nimueh.
Wait,
So-
are we going to be painting with them?
Yep, on the paper that you put them on top of. So do you want to start doing your drawing? And as it melts, you will create your work of art. I'd try and do the northern lights.
How?
And there's just loads of UV lights in the night sky.
Look at the Look what I made.
It's looking brilliant.
Do you know what we should do?
Yeah.
Once if we stack all of our ice what we have on top, and then when it melts, it will go down like that and make like a display of different colours.
Ooh, good
Shall we do it?
Yeah,
idea.
but wait.
Let's turn the paper around. Which paper shall we do it on?
My paper.
And then
Well, if we get a fresh piece of paper, you could always make a rainbow using all.
What are you making, Nim?
And now I need to
Waterfall,
bow.
blue sky, and grass.
That is
And now
beautiful, Nimueh.
Can I please borrow your yellow for the sun?
Clever girl.
how are you painting with it? Can we
Straight
get some
onto the
tissue over
metal
here on
tray.
aisle 10? We'll do 10. We will do 10.
And then
Alright, go get some tissues for him.
We're washing our hands. We're painting. We're washing our hands.
I'm
Nim, smile. Smile, guys. Right, say night.
But I want to.
Right, so experiment 7 is bubble science.
Boo-boo.
Yeah, you love bubbles, don't you?
Can we pop them?
So bubbles are a childhood magic, and we love bubble activities in this house. But what is the science behind bubbles? A bubble is essentially air wrapped in a soapy film. The outside and inside surface of a bubble consists of soap molecules, and a thin layer of water lies between these two layers of soap molecules, a soap sandwich. These layers work together to hold the air inside the bubble. Bubbles pop naturally once the water between the layers of soap molecules have evaporated. In colder temperatures, this process takes longer, and it can even freeze the bubbles.
Freeze?
Yeah, if it's cold outside.
We'll have to wait till winter for that one though.
Yep.
Or snowing?
For bigger bubbles, you can let your solution sit covered overnight.
But then it'll melt.
So, as you can see in front of our young scientists, they have 3 cups each. So in the first cup, would you like to put a cup of water?
Me first, me first.
Well, each cup needs 1 cup of water as a measurement. Right, well, while he's doing that, would you like to get started on the next step, Nimueh?
Yeah.
Okay, in your middle cup, you want to put 1 tablespoon of corn syrup. And we're using light corn syrup today.
Pull my spoon.
Put the spoon there. Because we're going yeah.
And in our third cup, you need 1 tablespoon of corn syrup
That.
and 2 tablespoons of dish soap.
So,
Now, our next step is to gently, very, very gently stir each one. So use 1 stick for one and 1 for the other.
But is this the even?
So, Nimueh, which one do you think will make the best bubbles?
This one. Because I put cream in it.
So you've chose the one with the dish soap in.
Yeah.
I
Okay.
reckon the dish soap as well, only because that's how you make bubbles.
Okay, so you think the dish soap one as well.
and the green one. Mix that.
Right, once that's all gently mixed together, you can pick up your first straw and put it in the tub with just water in.
So we use this one.
Do you think this one's going to make big bubbles, Nim?
Yeah.
The plain water one?
This one?
Yeah. Now blow some bubbles. How big are your bubbles? Let me have a look. We'll zoom in.
Well, we're
See your
getting
bubbles?
some bubbles, but they're not
see
sticking
your-
around.
Oh, they're going very quick, aren't they?
Yeah, but
They're fast bubbles.
Shall we move to the one with just syrup in it?
Okay, so that's that one because we swapped ours round, didn't we? And you're doing the middle one,
What
Anthony.
do I do with this one?
If you want to do it with
Yeah.
the purple straw, you can do. What do we think? So do we think that's more bubbles than the water or less
Go on, Nim.
bubbles than the
Let's
water?
see your bubbles. Oh, you're getting lots of bubbles there, Anthony.
can I please do that one now?
There's some really good bubbles.
No, let me do
Next one. The next one is the one with the dish soap in as well. So let's see if you were right.
Oh my. We were right.
You were right. Look how big that's going, Anthony.
We were right.
And now there's a trick that I want Daddy to show you. So just wait, pause, don't touch the bubbles. Pause for 2 seconds while Daddy shows a trick. Back away from the straws, don't touch anything.
I got bubbles over my hand.
What's my trick?
I want you to pick up another straw and I need you to stick it into the one with the syrup in. And then now I want you to stab a bubble slowly. And as we look closely, we will see that it doesn't actually pop it and it merges around it. You're not blowing, you're just sticking it in.
Okay.
And see how the bubble just forms around it?
Yeah.
And it doesn't actually pop the bubble. Would you like to have a go, Anthony?
I want to.
So that one's your corn syrup one.
You stick it in your corn syrup and then slowly stab a bubble with it. You can also do it with your finger.
I know.
Yeah.
I did it.
And it stops the bubble from bursting and you become one with the bubble. You become a part of it. Isn't that clever?
Star Wars.
And you can do it with anything. You can even use scissors. Yeah, would you like to try it with a pair of scissors?
Yeah.
Oh, there's some big ones here you can try.
Which one is your
That's the corn syrup one.
Okay, so put your scissors in there
Yeah.
and then slowly stab a bubble. Oh, that big one there, yeah, see? And it's not popped it. Clever girl.
Yeah, but only on the way out. You just stabbed a bubble
I
with a pair
won.
of scissors.
Bubble,
That's
bubble.
awesome.
Bubble.
Yay, science!
Did that work, our magic trick? Basically, the bubble didn't pop because the bubble wraps around anything that's already wet, filling any hole that would have occurred and forming the wall of molecules around it. Isn't that clever?
Yay!
Yay!
Anthony, you're nearly missing.
I think we might have to call it a day on that one while we dig the kids out the bubbles.
Say bye.